AI, machine learning, deep learning. If the first distinction to be made when trying to define AI is between AI and human intelligence, the second distinction is to be made is between the different manifestations of AI. The term AI was coined by John McCarthy in 1956. The same term is still being used today. But the difference between what John McCarthy was referring to in 1956 and what we call AI today is as big as the difference between the first proto car before even the Model T Ford was produced and a Tesla car, a self-driving car today. The category AI, in other words, has changed significantly. Importantly, within AI, there are a series of subcategories. Machine learning is a category within AI, and deep learning is a category within machine learning. We can think of these as being like Russian dolls nested within each other. Deep learning might be part of AI, but it's very, very different to the initial early forms of AI. Deep learning then is part of machine learning that is part of the broader category of AI. Increasingly, though not completely, when we refer to AI these days, we tend to refer to deep learning, the most sophisticated, the most advanced form of AI. The early forms of AI are often referred to as classical AI or good old-fashioned AI, GOFAE. These are basically when machines have been programmed to do something. In fact, we could even call something like Grasshopper a form of AI, but a primitive form of AI. The important thing is, the important aspect of it is it doesn't learn, it just does what it's programmed to do. Machine learning is the next step. Machine learning is able to train itself using vast quantities of data, and it challenges the popular myth that computers can only do what they're programmed to do. That was the initial assumption. As the term implies, machine learning is able to learn. At the same time, we must be very cautious when we're using the term learn not to confuse it with the way that humans learn. Deep learning is a relatively new development, and it's within machine learning. And this is really what has fueled many of the most significant recent advances in the field of AI. And as I mentioned before, it has become the dominant paradigm, so that somewhat misleadingly perhaps, it has become almost synonymous with AI within the popular media. It consists of a number of layers within a neural network, and that's what the term deep refers to, including possibly up to 1,000 or more layers. So why has deep learning taken off in the way that it has? There are a number of significant factors that have fueled the development of deep learning. First of all, and perhaps most obviously, the enormous advances that have been made in computation in terms of the algorithms that are available. But equally significant in some senses are the use of cloud services. In other words, we can connect through the cloud to GPUs elsewhere, which means that we don't have to have those GPUs on our computer. Another factor has been the intense competition and the investment that has got into AI. And increasingly now, as Kai-Fu Lee has commented, it is now a question of China, particularly Shenzhen, versus Silicon Valley. But there are other marketplaces competing in terms of AI. Famously, Vladimir Putin has said, whoever controls AI controls the world. There is enormous competition for AI right now. There are also many more college students working in the field of AI, and they're not just computational science students, they're also, for example, working in architecture. More and more architects are engaging with the field of AI. And finally, well, perhaps not finally, because there are many other factors, but one of the other significant factors is the fact that the amount of data that has been produced these days has got exponentially more. In the last 2 years, we have generated more data than throughout the rest of history. Data is the new oil. And all these factors have been contributing to the rise of deep learning.